Hello there, and welcome to this mini-series on pre-algebra. So what is pre-algebra? Well, it's as the name suggests, it's the thing you do before algebra. So I am mostly going to cover some math that's done before getting into algebra. So what is algebra? I guess you'll find out a bit later, but algebra is mostly the idea of having a variable. Sometimes you see the variable as the letter x, and so you may have heard of solving for x. So in this entire course, there will be none of that, but I will be introducing the building blocks that lead up to being able to solve for x. So here are a couple of assumptions that I need to make in order for this to go well. I need to make sure that you already know how to do the following things. So prerequisites. I hope that you at least know how to add numbers together, how to subtract numbers, how to multiply numbers, and how to divide. Basically, that's all you need. So as long as you know how to add, subtract, multiply, and divide, I think this should go pretty well. So with that aside, let's begin our first lesson, which is multiplying fractions. So I guess my first question for that would be, well, what is a fraction? And I have an example here of two fractions. So the first one is 2 over 3, and the other one is 4 over 3, and I'm trying to multiply them together. So I'm going to go off on another little side tangent here. So a fraction. All you need to know about fractions is that there's going to be some number on top of a fraction. I'll just make up an example here. 3 over 7. So all that 3 over 7 means is, what if I were to take the top number, 3, and divide it by the bottom number, 7? So we call this top number here a numerator. And the bottom number here we call a denominator. So you may hear me call them numerators and denominators. Sometimes I'll be a little bit lazy and I'll say the top number and the bottom number. Just keep that in mind. So if you have a hard time remembering which one is which, just remember that denominator, D stands for down, and the letter D is the first letter in the word denominator. So the bottom one is the one that's down, it's the denominator. So why bother with fractions? Well, in this example that I gave you here, 3 over 7, I can't do 3 over 7 in my head. You'd have to use a calculator for this. 7 just doesn't go well into 3, and that's why. So, if we tried to put that into a calculator, I'll grab my calculator here and try. 3 divided by 7, I'm getting 0.4285714. It goes on. It might just be better to write it as 3 over 7. That way I don't have to round off the number at some point, so I'm not losing information. 3 over 7 is something we would call an exact answer because we can choose to be as accurate as we want with the decimal places. So again, all you have to remember is a fraction is a number divided by another number, and hopefully that'll make sense. So let's jump into this example. 2 over 3 times 4 over 3. So I chose multiplying fractions as the first thing to show you. Normally when you're in elementary school, you learn how to add numbers first and then subtract them and then multiply them and then divide them. But you'll see very quickly in the next few videos why it's better to learn how to multiply first. This is actually the easiest operation to do. Very, very easy to remember. All you have to do is take the two numerators, so the two top numbers, and multiply them together. And then take the two denominators and multiply them together. Oh, that 3 doesn't look very nice. 3 times 3. So the top here, 2 times 4, the two numerators, I should say. 2 times 4 is 8, and 3 times 3 is 9. And that's it. That's the end of the story. So 8 over 9 would be our final answer. Not so bad, I hope. Let's try this next one, and it's going to be exactly the same steps. So 2 over 4 times 3 over 7, that's just going to be the two numerators multiplied together, 2 times 3, divided by the two denominators multiplied together, 4 times 7. So the two numerators multiplied together, 2 times 3 makes 6, and the two denominators, 4 times 7 is 28. So I'd like you to take a moment and actually let's figure out what this makes as a decimal. So take out your calculator for a moment and try to do this. The top number divided by the bottom number. So I'll give you a moment to do that. Actually, I'll do it in real time here. So let me know if you get the same answer as 0.214285714. And of course, this keeps going forever. I want to prove some kind of point to you. Is this the only fraction that could make 0.214285714? Well, it turns out there's another fraction that could do the same thing. If we tried to do 3 over 14, well, if we'd have to take out our calculator again. We'd do 3 divided by 14. And if you put that into your calculator, well, let's try. 3 divided by 14. I'm getting exactly the same answer. So what's the deal with that? It turns out that these two fractions, the 6 over 28 and the 3 over 14, we call these equivalent fractions. So what does equivalent mean? It means that they result in the same thing, basically. They both lead to the answer 0.214285714. So which one is correct and which one is incorrect? They're technically both correct answers, but many professors, at least, would prefer the second one, the 3 over 14. The reason is we call this one reduced. So they're both equivalent to each other, but the 3 over 14 has the smallest numbers in it. You know, we could actually, there is a pattern that you might have noticed. 6 over 28, if we divide the numerator and we divide the denominator by the same number, we actually get the reduced form. And so always try to do that. If you get to the end of the question, like you get an answer like 6 over 28, try to divide the top and bottom numbers by the same number. And if there is such a number that you can divide both of them by, be sure to do it, and then that will be how you reduce the fraction. Sometimes we have to reduce more than once. We may see this later. But yeah, so 3 over 14 is the better of the two answers. Let's try another one. So 2 over 8 times 7 over 3. Well, let's just do what we always do. 2 times 7 is 14. 8 times 3 is 24. And look at that. We have another number that possibly could be reduced. I'm going to try dividing by 2. And the reason I'm trying 2 is because I see a 4 and a 4. And if the two numbers that I just circled are both even numbers, then 2 will be a multiple of both of them, meaning we could divide each of them by 2. So 14 divided by 2 is 7. 24 divided by 2 is 12. And 7, we call 7 a prime number. All that means is there's nothing else we can divide 7 by other than 7. or 1, but dividing by 1 is going to give us, it's going to get us nowhere, so we don't bother with 1. So this would be as far as it goes. This is our reduced answer. Let's do another one. 10 times 1/2. So you're probably wondering, this doesn't make sense because we learned how to do a fraction times a fraction, but 10 isn't really a fraction. And to that I say, yes, it is. All you have to do to change any number into a fraction is divide it by 1. Now, why is that the case? I'll give you 3 examples to prove my point. Let's say 5, 7, and of course 10. Well, I'm claiming that 5 is just 5 over 1. Is that true? Well, we have a calculator handy. Let's use it. 5 over 1 means 5 divided by 1. And I'm going to take out my calculator and try that right now. 5 divided by 1 equals 5. So yes, my prediction was correct. Let's try that with 7, although I think you know where this is going. 7 divided by 1 equals 7 divided by 1 equals, in the calculator, 7 divided by 1 equals 7. And so, of course, I hope you've been convinced that 10 divided by 1 is going to make 10. So this works for any number. So you can even take note of this. You can say, let's put a note here. Any number can be put over 1, and that just means to do what I did up here, over 1, to become a fraction. So that means fractions can be compatible with any number that we choose to multiply it to. And you'll see later, this also works for division of fractions and addition of fractions and subtraction of fractions. It works everywhere. So you need something to be a fraction, just put it over 1. Let's go ahead and continue this. So now the two numerators multiplied together would give 10 times 1, and the two denominators would be 1 times 2. 10 times 1 is 10. 1 times 2 is 2. 10 divided by 2. Again, we could try to reduce this, but I'm noticing that 10 divided by 2, that makes a number that's pretty familiar. It would be 5. So our answer would be 5. Now here's a bit of a harder one, although really it's just the same steps as the ones we just did. When you have multiple multiplications, don't worry. All you can do is multiply all of the numerators together all at once. So 2 times 4 times 7, all divided by 7 times 2 times 4. Let's take out the calculator and try that. So 2 times 4 equals 8, times 7 is 56. 56. And 7 times 2 times 4 equals 56. Well, that's strange. We got the same number on both top and bottom. Could we have predicted that ahead of time? Well, yes. I asked this question here. 3 times 2, just as an example, 3 times 2 would be 6, but 2 times 3 would also be 6. So what I've just learned here is that the order of multiplication does not matter. It didn't matter if I did 3 times 2 or 2 times 3. The answer was the same. And that means that if we have just a big, long string of multiplications, we could actually rearrange the numbers. So I'm going to do this problem again down here just to show you what I mean. 2 times 4 times 7 over 7 times 2 times 4. Well, my 2 looks kind of silly. 7 times 2 times 4. we could at any point rearrange the 7, the 2, and the 4. And I'm going to do that. So 2 times 4 times 7. Well, we said the order doesn't matter. So this could be 2 times 4 times 7 down here. All I did was move the 2 here, move the 4 here, move the 7 here. They've all been accounted for. Now there's another pretty cool thing that happens. If ever you notice that there's a 2 on the top of a fraction and on the bottom, and this only works when they're all being multiplied, as you see right now, there's only multiplications. So this no longer works when there's addition or subtraction or division. But they're all multiplied. There's a 2 on the top and a 2 on the bottom. They cancel each other out. And the 4 with the 4 also cancels each other out. And of course, the 7 and the 7 also cancel each other out. So you're probably wondering, well, there must be nothing left. It turns out there's still 1 left. There's still a 1. If stuff cancels on the top and bottom of a fraction, you'll never get 0. If everything goes away, the answer is still 1. And well, why is that? Let's look at the answer we got the first time. We got 56 over 56. We could just say, well, that means 56 divided by 56. And well, what is 56 divided by 56? It is 1. So yes, everything canceled, but there's a 1 that's left over. And we saw that that just happened when we tried it a different way. So as long as we're consistent, we should get the answer each time. And that's about it for multiplying. I hope this made sense. I hope it was helpful, and I will see you in the next video.